Good morning, friends. Today we are going to discuss about the first topic of module 2 about the sinusoidal waveform. So in alternating quantity, the waveforms may be in many shapes like sinusoidal, square, triangular, sawtooth, etc. So an alternating waveform changes its magnitude and direction periodically. Many times, alternating voltages and currents are represented by a sinusoidal waveform. It is more useful than other waveforms when we compare with square, triangular, sawtooth, trapezoidal, etc. Because any waveform can be written in terms of mathematical model in terms of sinusoidal function with the help of Fourier series. The derivative and integration of sinusoidal waveform result in sinusoidal waveform only. So for the analysis purpose, this will be very helpful for analyzing the wave equations. The sinusoidal waveform can be easily analyzed and generated. So how we are generating the generation of alternating voltages? In alternating voltages, can be generated either by rotating a coil in a stationary magnetic field or by a rotating magnetic field with a stationary conductor. In both the cases, the magnetic field is cut by the conductors or coils and an EMF is induced in the coil according to Faraday's law of electromagnetic induction. It states that a current carrying coil is placed in a magnetic field, an EMF will be induced. It is nothing but Faraday's law of electromagnetic induction. The magnitude of the induced EMF depends upon the number of turns of the coil, the strength of the magnetic field, and the speed at which the coil or magnetic field rotates. Consider a rectangular coil of n turns of area capital A meter square and rotating in anti-clockwise direction with angular velocity of omega radians per second in a uniform magnetic field as shown in this figure. Let pi m the pi is the flux, m indicates the maximum flux cutting the coil when its axis coincide with x dash, that is in horizontal direction, reference position of the coil. When the coil is along x-axis dash, the flux linking with its maximum, that is pi m. When the coil is along y dash, that is parallel to the lines of flux, the flux linking with its 0. The coil rotates through an angle theta is equal to omega t at any instant t. At this instant, the flux linking with the coil is pi is equal to pi m into cos omega t. According to Faraday's law of electromagnetic induction, E is equal to minus n into d pi dt. N is number of rotations and n into d pi dt, we are substituting the value of pi over here. Pi is equal to pi m cos omega t and we are getting n into pi m into omega into sin omega t. So for all this, n pi m omega has been replaced by Em, that is maximum value of induced EMF. N is nothing but number of turns. When omega t is equal to 0, sin omega t is equal to 0, then E is equal to 0. 0 into anything is 0, sin 0 is 0. Then omega t is equal to pi by 2, then sin pi by 2 is 1, then we will be getting the maximum value, that is E is equal to capital Em. If the induced EMF is plotted against time, a sinusoidal waveform is obtained. So the terms related to alternating quantities, the shapes of the waveform triangular, square and alternative sinusoidal waveform. A waveform is a graph in which The instantaneous value of any quantity is plotted against the time. Here, the waveform has been drawn versus voltage versus time. Time has been taken in the x magnitude, x-axis, and voltage has been represented in y-axis. Cycle one complete set of positive and one complete set of negative forms one cycle. Then frequency, the number of cycles per second of an alternating quantity is known as its frequency. Cycles per second, or else we can represent it as hertz. It is denoted by, frequency has been denoted by a letter small f, and it is measured in hertz. Time period, the time taken by an alternating quantity to complete one cycle is called its time period. It's denoted by capital T and is measured in seconds. T is equal to 1 by F. Amplitude, the maximum positive or negative value of an alternating quantity is called the amplitude. Phase, the phase of an alternating quantity is the time that has elapsed since the quantity has last passed through 0 point of reference. Then phase difference is the term used to compare the phases of two alternating quantities. Two alternating quantities are said to be in phase with each other or when they reach their maximum and zero values at the same time. The maximum value may be different in magnitude. A leading alternating quantity is one which reaches its maximum or zero value earlier compared to the other quantity. A lagging alternating quantity is one which attains its maximum or zero value later than the other quantity. A plus sign, when used in connection with the phase difference, denotes lead, whereas a minus sign denotes lag. Vs equal to Vm sin omega t and Vb is equal to Vm sin omega t plus pi. It is leading pi degree angle. Here the quantity B leads by a phase angle pi as shown in the figure. Then root mean square, that is short form, it has been represented as RMS or effective value. Normally the current is measured by the amount of work it will do or the amount of heat it will produce. Hence RMS or effective value of alternating quantity is defined as that value of steady current, that is direct current, which will do the same amount of work in the same time or would produce the same heating effect as when the alternating current is applied for the same time. So this figure shows the positive half cycle of a non-sinusoidal alternating current waveform. The shape is not sinusoidal. The waveform is divided in m equal intervals. Here the m has been represented, m equal intervals of time each of duration t by m. Let the average values of instantaneous currents during these intervals be respectively I1, I2, I3, etc. up to Im. This waveform is applied to a circuit consisting of a resistance of R ohms. The work done in different intervals will be I square RT. So I square into R into each interval has been represented as T by M, comma for the second current I2 square R into T by M, etc. It has been continued up to Im square R to T by M joules. Thus, the total work done in T seconds on applying an alternating current waveform to a resistance, we can represent R is equal to I1 square plus I2 square plus Im square divided by M into R into T joules. Let I be the value of the direct current that while flowing through the same resistance does the same amount of work in the same time T. So I square RT, so I square has been represented I1 square plus I2 square plus etc. Im square divided by M is nothing but time interval into RT has been represented as it is. So that I square is equal to I1 square plus I2 square plus etc. Im square divided by M. Hence, RMS value of the alternating current is given by RMS is equal to root of I1 square plus I2 square plus etc. Im square divided by M, that is square root of mean value of I square. The RMS value of any current I of t over the specified interval T1 to Tt is T1 to T2 is expressed mathematically as IRMS is equal to square root of 1 by T2 minus T1 into integration of the lower limit is T1, upper limit is T2, then I square of T into dt. The RMS value of an alternating current is of considerable importance in practice because the ammeters and voltmeters records the RMS value of alternating current and voltage respectively. The RMS value of a sinusoidal waveform figure shows a sinusoidal waveform. Then V is equal to Vm sin theta. The theta ranges between greater than 0 and less than 2 pi, that is 180 degree. So Vrms is equal to square root of 1 maximum angle, that is 1 by 2 pi time period into 0 to 2 pi is the angle difference. V square of theta into d theta. Then square root of 1 by 2 pi integration of 0 to 2 pi. We are substituting the V value Vm sin theta d theta, that is V is equal to Vm sin theta so that V square will be Vm square sin square theta d theta. So this Vm square is a magnitude we are taking then before to the integration. So Vm square divided by 2 pi, then 0 to 2 pi integration sin square theta d theta. We know that sin square theta is equal to 1 minus cos 2 theta by 2. After that we are integrating 1 by 2. It is nothing but theta by 2 minus cos theta, integrating minus cos theta is equal to minus sin 2 theta by 2 into 2, that is 1 sin 2 theta again into 2, that is 1 by 2, so 4. So the limit is 0 to 2 pi. Then after substituting, we are getting the final value Vm by root 2, that is 0.707 Vm. Crest or peak or amplitude factor, it is defined as the ratio of maximum value to RMS value of the given quantity. Now the peak factor has been represented by a letter Kp, that is equal to peak value is equal to maximum value divided by RMS value. Thank you.